Right now, parked in your neighbor's driveway or sitting in a showroom 2 miles from where you are, there is a machine that is watching, learning, updating itself overnight while its owner sleeps. And the company that built it knows more about how you drive, where you go, and how you behave behind the wheel than any car manufacturer in the history of the automobile. This is not science fiction. This is a Tesla. And the technology running silently inside it is unlike anything the automotive world has ever seen. Most people think Tesla's secret weapon is the electric motor. It isn't. Most people think it's the battery. It isn't that either. Tesla's real secret, the thing that separates it from every other car company on the planet, is something far more invisible, far more powerful, and far more controversial than a battery pack or a motor. It is a computer on wheels. A data-collecting, self-updating, artificially intelligent machine that happens to also take you from point A to point B. And once you understand what is actually running inside a Tesla, you will never look at a car the same way again. To understand what makes Tesla's technology so radical, you have to go back to the moment the automotive industry made a decision it is still paying for. It is 2006. General Motors, Ford, Toyota, the biggest car companies in the world, are building vehicles the same way they have built them for 100 years. You design the car, you manufacture the car, you sell the car. The relationship ends at the dealership. Once that vehicle leaves the lot, the manufacturer's involvement is essentially over. If something breaks, you bring it to a mechanic. If they want to improve the model, they wait until next year and release a new version. This model worked perfectly for a century. It was efficient, profitable, and deeply understood by everyone in the industry. And then Elon Musk looked at it and decided it was completely wrong. Musk's insight, the one that every car executive dismissed as fantasy in 2006, was simple. A car is not a product. A car is a platform. And like any platform, it should be able to receive updates, improve over time, and get better the longer you own it. Not worse. Better. This one idea, that a car could be treated like a smartphone, required Tesla to rebuild the entire architecture of what a vehicle even is from the ground up. And what they built is still not fully understood by most people who own one. Every Tesla runs on a central computer system that Tesla calls its Full Self-Driving Computer, or FSD chip. The version currently inside newer Tesla vehicles, the Hardware 4 chip, is a custom-designed processor built specifically by Tesla, not bought from Intel, not licensed from Qualcomm. Designed in-house from scratch to do one thing with extraordinary efficiency: process visual information from cameras at superhuman speed. Think of it this way. Every time you drive a Tesla, the car's 8 external cameras are recording everything around it simultaneously. Every pedestrian, every traffic light, every lane marking, every other vehicle. The FSD computer is processing all of that visual data in real time, building a 3-dimensional model of the world around the car, and making thousands of micro-decisions every second. Not hundreds. Thousands. Andrej Karpathy, who served as Tesla's director of AI from 2017 to 2022, described Tesla's approach as fundamentally different from every other autonomous vehicle program in the world. Where companies like Waymo rely on expensive LiDAR sensors, laser-based systems that bounce beams of light off objects to measure distance, Tesla made a decision that shocked the industry. It ditched LiDAR entirely. It bet everything on cameras and neural networks. On teaching a computer to see the world the way a human does, through vision alone. Karpathy called it a data engine. The idea is as elegant as it is audacious. Every Tesla on the road is collecting data. Every time a driver takes over from autopilot, every time the car encounters a situation its system hasn't seen before, every time a near miss happens, that data is flagged, uploaded, and fed back into the neural network. The fleet learns. Every single car gets smarter every single time any car encounters something new. As of 2024, Tesla's fleet had accumulated over 5 billion miles of real-world driving data. 5 billion. The next closest competitor had less than 50 million. That is not a gap. That is a canyon. And this is where the story gets genuinely unsettling. in the best possible way. Because Tesla's technology doesn't just make the car drive better, it makes the car know you. Every Tesla stores a detailed log of your driving behavior, your acceleration patterns, your braking habits, how often you use autopilot, where you charge, how long you sit in the car before driving. The car knows your commute better than you do. It can predict, with remarkable accuracy, when you are likely to need to charge based purely on your historical patterns. Before I continue, hit that subscribe button right now. Behind the Tech uncovers these hidden technology stories every single week. Without further delay, let's get back to the video. But Tesla's technology goes even further than data collection and autonomous driving. There is something inside every Tesla that almost nobody talks about, and it is perhaps the single most disruptive feature the company has ever built. Over-the-air updates. This sounds mundane. It is anything but. In 2013, Tesla pushed a software update to its entire Model S fleet that changed the car's charging behavior to reduce fire risk. Not a recall, not a trip to the dealership. An update, pushed wirelessly, overnight, while the cars sat in driveways across America. The implications of this are staggering. In 2020, a software update added 10 additional miles of range to certain Model S and Model X vehicles. The hardware was identical. The battery was identical. Tesla had simply unlocked capacity that was already there, using code. In 2021, a single update improved the braking distance of the Model 3 by nearly 20 feet. 20 feet. That is the difference between a near miss and a fatality. No other car company can do this, not at scale, not overnight, not without a single customer setting foot in a dealership. Sandy Munro, the legendary automotive teardown engineer who has spent decades analyzing vehicle architecture for major manufacturers, examined a Tesla and declared its electrical architecture to be a decade ahead of every other car company on the planet. Not a year, a decade. He described the wiring harness, the network of cables that runs through a vehicle, as revolutionary. Where a traditional luxury car might have kilometers of wiring connecting hundreds of separate control modules, a Tesla runs on a centralized computing architecture with a fraction of the complexity. Fewer parts, less weight, more reliability, and critically, the ability to update everything from a single central system. This centralized approach is also what makes Tesla's autopilot and full self-driving systems so different from the driver assistance features in other vehicles. In a traditional car, the lane-keeping assist and the adaptive cruise control and the automatic emergency braking are each run by separate, isolated modules from separate suppliers. They do not talk to each other elegantly. They were not designed together. Tesla's systems, by contrast, are fully integrated at the software level, designed as a single unified intelligence rather than a collection of bolt-on features. And then there is the Dojo supercomputer. In 2021, Tesla revealed that it was building one of the most powerful supercomputers on the planet, not to run the cars, but to train the neural networks that eventually get deployed into the cars. Dojo is a custom-designed supercomputer built entirely around training AI on video. Specifically, the billions of hours of real-world driving footage that Tesla's fleet captures every single day. The scale of Dojo is almost incomprehensible. Tesla's goal was to build a machine capable of processing an exaflop of computing power. That is 1 quintillion operations per second. To put that in terms that actually means something, a single exaflop of computing power is roughly equivalent to every person on Earth doing 1 billion calculations per second simultaneously. Tesla was building that. To train a car. Here is what all of this means for you, right now, even if you never buy a Tesla. The technology inside a Tesla has already forced every major car manufacturer to fundamentally rethink what a vehicle is. Mercedes, BMW, General Motors, Volkswagen, they are all now racing to build centralized computing architectures. They are all building over-the-air update capabilities. They are all trying to hire AI engineers who understand neural networks. They are all trying to close a gap that gets wider every single day. The car you drive today, whether it is a Toyota or a Ford or a Honda, is being redesigned right now because of what Tesla proved was possible. the navigation system that just got updated on your dashboard, the safety feature that your car manufacturer just pushed silently last month, the connected services your dealership keeps trying to sell you. All of it traces back to one company deciding that a car was a platform, not a product. And here's the thing that should stop you cold. Tesla is not finished. The technology inside today's Tesla is not the destination. It is the foundation. The Dojo supercomputer is still being scaled. The FSD chip is still being updated. The neural networks are still learning from every mile driven by every car in the fleet, every single day. The car parked in your neighbor's driveway right now is not the same car it was 6 months ago. It is smarter. It has better reflexes. It can see further, react faster, and understand the world around it more completely than it could when it rolled off the assembly line. And 6 months from now, it will be smarter still. That is not how cars work. That is not how cars have ever worked. Until now. Click on this video right here, how Skype became the world's most hated app. Because what happened to Internet Explorer and what happened to Skype are the same story told from opposite directions. One won too much and stopped caring. One was handed a winner and broke it. The outcome was identical. I'll see you there.